Assalamualaikum warahmatullahi wabarakatuh. Good morning, sir, and all my friends. Let me introduce myself and my partner. I am Qarina Mardatilah, and my partner is Iffah Ayuza. In this opportunity, I would like to present elements of 4A groups. First, I will explain about the distinction of C elements and other elements in the same group. And then I will explain about element C, and other discussion will be explained by my partner. If we talk about elements C have distinction with other elements in the same group. First, element C or carbon atom have 4 valence electrons. That means 4 valence electron form electron pair together with other atoms forming covalent bonds. And the second, the radius of carbon atom is relatively small. When we view it in periodic table of elements, carbon atom are in period 2. That is, carbon atom is only have 2 outer shell. Ergo, the radius of atom must also be small. Since the radius of carbon atom is relatively small, covalent bond form relatively strong. And the third, carbon atom can form carbon chains. In this table, we can see the properties of the elements. Ionization energy, element C, bigger than silicon, germanium, tin, and lead. And then melting point, element C, bigger than silicon, germanium, tin, and lead. Because in the element C or carbon atom have a covalent bond relatively strong. And then the greater attractions bond, more energy is needed to break this bond. Pure carbon occur naturally in 2 modifications. First, diamond, and the second, graphite. In both these forms are carbon atoms linked by covalent bond to give giant molecule. The difference of diamonds and graphite is diamond. First, the diamond structure is rigid, and the second, each atom surrounded tetrahedrally and extremely hard. And then graphite consists of layer of fused and thick membrane of carbon atom. In this table, we can see the physical properties of diamond and graphite. At room temperature, thermodynamically graphite more stable than diamond. However, the density of diamond much greater than the graphite. Graphite can be converted to diamond at very high pressure. Carbon forms several anions, especially in combination with the most electropositive metal. In these carbide compounds, there is considerable covalence as well as ionic bonding, with the proportion of each depending on the metal. The best characterization carbide ions can see in this table. Next, my partner will be explained.
Okay, now I will explain about silicon. So, silicon has the atomic number 14, and it is a hard, brittle crystalline solid with a blue-gray metallic lustre, and it is a tetravalent metalloid and semiconductor. This is the crystal structure of silicon, and this is the symbol of silicon. There are some element properties of silicon as we can see from this slide. Okay, next we will talk about germanium. So the atomic number of germanium is 32 and the symbol is Ge with the crystal structure like this. Germanium is a silvery gray metalloid intermediate in properties between the metals and the nonmetals. The name germanium derives from the Latin word Germania. And this is the element properties of germanium, and this is the picture of germanium. Next, tin with the symbol Sn and the atomic number 50. Tin is a soft, silvery white metal with a bluish tint and known to the ancient in bronze and alloyed with copper. Tin is widely used for plating steel such as food containers and metals used for bearings and soldering. This is the crystal structure of Sn or tin. And as we can see from this table, there are some element properties of Sn. Okay, the last is lead with the symbol Pb, which is an abbreviation of the Latin word for lead, plumbum. Lead is a soft, silvery white or grayish metal, and lead is a very malleable, ductile, and dense, and it is a poor conductor of electricity. Lead is known in antiquity or believed by the alchemists to be the oldest of metal. Lead is highly durable and resistant to corrosion. Okay, this is the crystal structure, and there are some element properties. Okay, next we will talk about the reactions. First, the reaction with acid. As we can see from the left side, this is the reaction of acid with carbon, silicon, germanium, tin, and lead. And next, the reaction with alkalis. Only carbon that doesn't react with alkalis. And last is reaction with oxygen, and this is the reaction. Okay, next the use of each element. The carbon, in an amorphous form, carbon is used for steel making, as a tire filler, respirator, and as activated carbon. And also, the graphite form is used for the pencil industry, and the diamond is another form of carbon used for jewelry. Next, silicon. Silica is the main ingredient in making glass, and 50% pure silicon is used for making alloys, and silicon has also been used as semiconductors since 1950. Next, germanium, used in wide-angle camera lenses and objective lenses for microscopes. It can also be used as an alloying agent in fluorescence lamps and as a catalyst. Germanium is transparent, so it can be used in infrared spectroscopes. Next, tin. Tin is the most widely used for making solder, and tin is also a material for making several alloys, and tin fluoroxide is used as cerulean blue pigment. And last, lead. 80% of lead produced is used as a material for making batteries, and other use of leads are as ballast, pigment, antidote to radioactive material. Okay, that's it from our group. Thank you so much for your attention. Assalamualaikum warahmatullahi wabarakatuh.